Thanks for coming back again for those that have subscribed. If you are yet to subscribe, please click on the subscribe button and also on the bell beside it to notify you when we drop a new video. Thank you for doing that. Now, we want to look at how to prove that the answer for this particular exponential equation is equals to 2. Like we have 3 raised to the power n plus 4 raised to the power n equals 5 raised to the power n. So looking at it, automatically we should agree that the value of n is 2. But however, how could we solve this? This is not an equation that could be solved by just taking the division and just solving it anyhow using the index form of each numbers. So, but however, I have 3 methods we can use here to solve this. So let's look at the first one. I have the Pythagorean triple. 3, 4, 5 are Pythagorean triple. So 3, 4, 5 are Pythagoras triple. So meaning if I have this triangle and here is 3, here is 4 and here is 5, it works out. So meaning that the 5 squared equals 4 squared plus 3 squared. So comparing that to 3 raised to the power n plus 4 raised to the power n equals 5 raised to the power n, we should see that n equals 2. So that is first method, Pythagoras triple. So however, let's try the second method to see how it goes. So I'm going to try this with the Fermat last theorem. The Fermat last theorem states that 3 set of real numbers, suppose we have 1, 2, 3, cannot satisfy an equation at the same time. These 3, trying these 3 will not just satisfy an equation at the same time. So let's try using 1 firstly. So if x is 1, let's plug in 1. If x equals 1, that means 3 raised to the power 1 plus 4 raised to the power 1 equals 5 raised to the power 1. So and then that gives us 7 plus 5. So meaning left hand side is not equals to right hand side. So I think 1 doesn't work for that. So still using the Fermat last theorem, we have to plug in 2. So then meaning we have 3 raised to the power 2 plus 4 raised to the power 2 equals 5 raised to the power 2. And this gives 9, this gives 16, this gives 25. So actually 9 plus 16 is 25. So meaning that left hand side is equals to right hand side. So we can say this is correct. So lastly, I'm going to use the last theorem, which is one of the trigonometry identity. So how do I go about that? So if I have to work with that, I'm going to divide with the highest, with the highest number. So meaning I'm going to have 3 raised to the power n all over 5 raised to the power n plus 4 raised to the power n all over 5 raised to the power n equals 5 raised to the power n all over 5 raised to the power n. So if I take this common factor, I'm going to have 3 all over 5 all raised to the power n plus 4 all over 5 all raised to the power n, and this gives us 1. Anyway, sine square a plus cos square a all equals 1. So if I plug in this into 1, I'm going to have 3 all over 5 raised to the power n plus 4 all over 5 all raised to the power n would be equals to sine square a plus cos square a. So comparing what we have here, this is 3 all over 5 n raised to the power n. So which in place, we take place of what? Sine square a, and 4 all over 5 we take in place of cos square a. So we can conclude by comparing these two equations that n is equal to 2. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.